terms of giga-electron-volts, the mass of an electron is 0.000511. To answer this question, you need two pieces of information from the lesson. So you've already seen it by the time you're getting to this homework. Exercise 2, it said the mass of an electron was that, and we wrote it in scientific notation today during your lesson. And we rewrote it as 9.10938.291 times 10 to the negative 31st kilograms. Then a little bit later on in the lesson, it defines a giga-electron volt. And so then it says the 1 giga-electron volt is equal to 1.783 times 10 to the negative 27th kilograms. To change the mass of an electron from a kilogram to giga-electron volts, we are going to divide. Actually, I think exercise 2 may have even been from lesson 11, not necessarily lesson 12. So we have 9.10938.291 times 10 to the negative 31st divided by 1.783 times 10 to the negative 27th. Okay, this was something that you learned last year. Remember, we're going to divide these pieces. But when you subtract negatives for the exponent, you should have 10 to the negative 31 minus a negative, I don't have enough room, minus a negative 27. If you are subtracting a negative, it is the same thing as adding the opposite. So our exponent is still going to be negative because the 31 is farther into the negatives than the 27. So we're going to have negative 4 as our exponent. We do still have to divide those numbers out front. 9.109 divided by 1.783, which is approximately 5.11. Oops. The negative exponents make numbers really, really tiny. So we should have 5, 1, 1, but the decimal is going to move this way, 4 spots. So we have 0, 0, 0. And that is what we started with. So we have verified that when we convert the mass of an electron using giga-electron volts, we get this value here. So this is giga-electron volts. So the verifying part is you showing your work, not just getting the correct answer, because you are supposed to get that answer. You've got to show the steps to get there.